Okay, so we're just quickly going to take a look at another example of graphing. So we're going to do this one and get all of the information. So let's start with our step one. Okay, so our step one is to get the y-intercept. Okay, that's the very first thing we do because it's in standard form. So our y-intercept we are already given, right? It's -21. So what I'm going to do is I'm going to write it underneath it. Y-intercept is equal to -21. And then I'm going to box it. Okay? And then we're going to go on to our second step. So our step number 2 is to get our zeros. Okay, so when we get our zeros, we need to do the window method. So we're gonna draw our lovely little window. And we're gonna plug in the information that we know. Right, so we know that x squared goes in the top left. We know that -21 goes in the bottom. And then we know that these two equal 4x. Okay, so now we need to find what these two squares are. So what we're gonna do is we're gonna take our little chart and we're gonna try and figure out two things that are going to multiply together to give us 21 and add together to give us 4. So let's start. So -21 and 1 will give us 21, right? And then +21 times -1 is also going to give us 21. And then if we take a look at 3 and -7, that will give us 21. And -3 and +7 will also give us -21. So then we're going to take a look and we're going to add them together to see if any of these equal 4. So -21 plus 1 is going to give us 20. Wrong. This one's going to give us -20. 20. Wrong. 3 plus -7 is going to give us -4. Nope. -3 plus 7 is going to give us +4. So these are our numbers. Okay, so we then take these two that we just found and we plug them back into our window. But don't forget that we need to add x when we plug it back in. So I'm going to put a 7x there and a -3x there. And then we can take the information that we know and put it outside of our window. So x, we pull this 7 out, we pull this -3 out, and we now have our zeros. So we write this in our factored form. Okay, so y equals x plus 7 and x minus 3. And then we need to write our zeros. So when we write our zeros, don't forget when you take these out, the sign changes. So this goes to a +3. And when we take this one out, it goes to a -7. So our zeros are -7 and 3. And then box that. And then our step 3 is to find the axis of symmetry. Okay, so what we do with the axis of symmetry is we take our two zeros and we add them together. Okay, and then we divide them by 2. So this gives us -4 over 2, which gives us -2. So our axis of symmetry, which is our x, gives us -2. And we're going to box that. Okay? And then we're going to do our step 4, which, let me see if I can find a different color. So our step 4 is to get the vertex. Okay, these are very similar steps to what we did yesterday. So with our vertex, we take our factored form, so we take this equation here. So y equals x plus 7 and x minus 3, and we plug our x value that we just found into it. So we get -2 plus 7, and we get -2 minus 3. And then we get, so I'm going to move it over here, so we get -2 plus 7, which is 5. And -2 minus 3, which is -5. So we get this at -25. Okay, so that was our y value for our vertex. So we end up getting our vertex as -2 and -25. And then with this information, we can then go plug our information back into all of our graphs, because we now have the y-intercept, we have the zeros, and we have the vertex. So when we're plotting it, let's see if I can make something. We would start with our y-intercept. So let's say that our y-intercept, I'll just use this for now. So our y-intercept is at about -21, so we'll just say that's right about here. And our zeros are at -7, so we'll go about down here for -7 and 3. There. And then our axis of symmetry is at -2. Somewhere around here. And then our vertex is at -2 and 25. So we would have it around here. And then we would plot or draw our line, our parabola. It is not a pretty looking parabola on my part, but that's okay. Okay, so we find all of our information and then we plug it back into the graph. That definitely did not go through that one. So now we're going to be talking about squares. So when we talk about squares and square roots, it is a perfect square is numbers that we can find a square root of. Okay, so it is a number multiplied by itself. So when we look at this, 1 times 1 is 1, right? 4 times 4 is, or sorry, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 36. 49. I think that one is 64. Give me 2 seconds. This one is 81. I believe that's 64. We're going to go with it. 100, etc., etc., etc. Okay, so it's times itself. So it's just the number multiplied by itself. So that's something you need to note when we go to the next page. So factoring using an area model. So when we talk about perfect squares, there's a few things that we can do. So what we can do, I'm just going to show you so then it'll make more sense when we explain it. So let's do what we would normally do. So we would put when we factor this out, we can factor it as x minus 3 and x plus 3. Okay, because with a perfect square, you can do its multiples in here. But the thing that you have to note is that one is going to be a negative and one is always going to be a positive. Okay? And another thing that you have to note is that we have no x term, right? So when there's no x term, it usually means that it is a perfect square. And what I mean by no x term is we don't see x squared minus 2x minus 9. Okay, so there is no x term. And then we have to find the two things that multiply to 9. And then one has to be a positive. One of them has to be a positive, and one of them has to be a negative. Okay, so then we take a look at the next one. But then one thing we can do is like we can actually plug it into here, so we can have the x minus 3, x plus 3, and then we do our xx, x minus 3x plus 3x, and then negative 9. Right, so then when we take a look at, so this is us expanding it, so this is what you're going to see when we expand it. So we would plus 3 minus 3 is going to give us 0 x. So then when we write it out, we are going to do, remember we write it out going this way, we write it as x squared minus 9. Okay, so let's take a look at the next one. So we know that there is no x term, perfect square. Okay, so we're going to take a look at this one. So what two things multiply to 49? You can take out your multiplication chart. Oh, sorry, mine's on the floor. So we can take our multiplication chart out. And if we take a look at where there is a 49 on here, we have to make sure the numbers are going to be the exact same. So I have 49 here. So if I go up, it's 7. If I go across, it's 7. So this is going to be x minus 7, x plus 7. So those are our factors. And then we can do the same thing. We can even plug it in here again. So x minus 7, x plus 7, we get x squared minus 7x plus 7x and negative 49. And then when we add these together, we get 0. So then when we write it, 2x minus 49. And then these two, so take a look at our multiplication chart. Where can we find 81 on here? If we go through, we find 81 here. So 81, we look up, there's a 9. We look over, there's a 9. So that is a perfect square. We can tell it's a perfect square because again, there's no x term. Okay, so then we go x minus 9, x plus 9, and you can check it and you'll get x negative 9 plus 9, we would get 81, x squared minus 9x plus 9x, that gives us 0, so we get x squared minus 81. Okay? And now one thing we can do with this one here. It's a perfect square, okay, but there's a number in front. So what we have to do for this one, this actually has a shortcut to its answer. So what multiplied together gives us 25? If we take a look at here, we can go find 25 on here and 25. So 5 times 5 gives us 25. So it is multiplied by itself. So we can do 5x, and then we take a look at this here. So 64. So go back to our multiplication chart, and we take a look, where is 64? So we have 64 here, and we can look up 8, across 8. So we would do minus 8 and 5x plus 8. Okay, so we can do that. I'll add another bracket on that side because it's a perfect square. Okay, so again, perfect squares have no x terms, and one always has to be positive and one always has to be negative. So you have this sheet and I want you to fill it out with me. Okay, so when we identify difference of squares, so if we identify that perfect square, so factoring differences of squares, there is no x term, okay? And there is one negative term. And all terms are perfect squares. Okay, so remember that perfect square is when the number can be multiplied by itself. So if we take a look at x squared minus 81, so this number here is a perfect square because it is 9 times 9, right? It is multiplied by itself. But when we look at x squared minus 20, there's no two things, no two same numbers that can multiply to 20, right? We can reach 20 by doing 5 times 4, but we can't reach 20 with a perfect square. So we can't factor this, okay, because it's not a perfect square and there is no x term. So we actually cannot factor it. Okay, so then when we look at how to factor a difference of squares, we can use the area model, right? So we can go and we can say that this is, because it's 16, so if you can use your little cheat sheet here if you want to write something like this down. So 16, we can do x plus 4 and x minus 4. And then we can put it back in and we do x plus 4, x minus 4, and then we have x squared, 4x minus 4x, and negative 16. So these two equal 0x, so when we write it out, we get x squared minus 16. Or we can do the shortcut to the answer when we have something like this, and we can do, because it is a perfect square, right? When we look at this sheet, 2 times 2 is 4. right? 2 times itself is 4. And we can see that it is 4 right there. And we can see that this one, this number there, is 5 times 5. So when we factor that out, we can put a 5x, and this is going to be plus 2 and minus 2. So 5x plus 2 and 5x minus 2. And that's our answer. So we can go through a couple of these practice questions together. We've done a few of them on the other page. And you can use an area model if you need to. Okay, so what we're going to do is we're going to take a look at number 2. So there's no x term. Okay, we see that there is a negative. Oh, we see that there is a negative term. So we know that we can use the perfect square shortcut. So what multiplies together to get 25? 5. So when we write it in, you don't even have to do the area unless you want to, the area model. So we can go x plus 5, x minus 5. And that's our answer. So let's go down to a trickier one. So 6. So what? First of all, let's take a look. There's no x value, right? None. Can this number be broken down into a perfect square? Yes. 4 times 4 is 16. So we can go back over and we can say this one's going to be a plus 4 and a minus 4. And what together equals 9? 3 and 3 equal 9. So we can do 3x plus 4 and 3x minus 4. Okay? So again, when we're identifying difference of squares, there can be no x term. There has to be one negative term. So this number has to be a negative, and then when we write it out, it has to have one negative term. And all terms have to be perfect squares. So if we see something like this, both of those have to be perfect squares. Okay? They always have to be perfect squares. So you're going to try these on your own, give it a shot, see if you can do it. I just have an extra piece of paper underneath. Okay? If you have any questions, you let me know.